Welcome back. I'm Chris Moore with HVAC Pro Blog, and I'm excited to share with you a recorded webinar that I created for my Patreon members 1 year ago. This training, Causes of Temperature and Comfort Problems, is extensive when it comes to ACA Manual ZR for zoning and their appendix number 1. So I take a lot of that information combined with my personal experience to talk about how fenestration, insulation, infiltration, moisture, load and duct sizing, duct leakage, and balancing impact comfort in a home. Without further ado, here's the training. So some of the things that cause comfort and temperature issues in a home are the fenestration. Fenestrations would be doors and windows, right? The insulation of the home, how well it's air sealed, or the infiltration of the house. Moisture control also would obviously cause comfort problems because as humans, we really are susceptible to comfort and humidity, okay? That's why in a humid climate, we always have to make sure we satisfy the latent load, right? So if we have moisture issues in a house, obviously we're gonna have comfort problems. I'm gonna get into that. We'll talk about load and duct sizing, if it's too big or too small. And then of course, duct leakage and air balancing. All of these issues can cause comfort problems in the home that most likely just zoning the system isn't gonna fix the root of the problem. So typically we wanna fix this problem first, okay? So let's get right into windows. So windows, glass doors, skylights, that's fenestration. And what you're gonna find is there's a lot of radiant heat loss in the wintertime with windows. The U value is very, very low compared to every other portion of the wall or ceiling or even the floor. So because of that, what you're gonna find is you're always gonna feel like you're losing heat to these devices. And if you're within 2 feet of a window, let's say your couch is up against a bay window or something, or a skylight, and it's on the second floor of your house, and you like to sit there and read or something, you're always gonna feel cold because the window is always gonna be colder than your body, right? It's called radiant asymmetry. And I've done many blogs and many videos on that. Certainly check out YouTube. There's a ton of great content on my channel there. I'm just gonna remind you, heat loss also comes into effect with windows. Everybody kind of assumes, well, it's just the U value and the amount of heat going through it. Obviously, it's lower than a wall. But remember radiant heat loss as well. And then, of course, in the summertime, you have to remember the solar heat gain, okay? So the way to control solar heat gain, obviously, is to throw up some blinds or shades or use a really good low E window, right? A very high U value. So really important, don't just assume zoning out a system for a room that has a lot of glass is gonna fix the issue, okay? You're gonna have to address the glass problem. And actually, guess what? Putting up blinds and stuff is probably cheaper than zoning out or adding equipment to a home. So always look at the obvious stuff first, okay? All right, so let's talk about insulation. Poor insulation, obviously, infiltration is the first one. We really should talk about that first, but it's in the next slide. You want to air seal before you insulate a house, right? Just like you air seal a duct system before you insulate a duct system. If air is moving through the insulation, it does no good, all right? But insulation is something that you can very quickly and easily see in an attic, even in a wall. If you were to take off a wall plate and put a probe on the side of an electrical outlet, obviously be very, very careful. Use a non-conductive one. I like the plastic needles that you would use in knitting. You can get them at any of those craft stores. First thing to take a look at, obviously with poor insulation, you're gonna have a warm surface temperature, let's say on an attic ceiling in the summertime, all right? And you're gonna feel that radiant gain on your body. All right, there's gonna be radiant transfer from that very warm or cold floors and cold walls in the winter up here in the Northeast. Like actually in my office, I have an overhang on half of my office. My desk used to be on that side of my office. If you remember from some old videos, it was cold all winter because I'm sitting on my chair's on a cold floor and I can feel the heat radiating off of me, and I have that radiant asymmetry issue, okay? So poor insulation, if we insulate that, in my instance, in my floor, we put insulation in there, that we blew it right in, dense packed it, and it was warmer because the floor stays warmer, okay? And therefore I don't lose as much heat radiant to the floor. Or ceiling in an attic, or knee walls in a second floor of a cape, right? All of these temperature issues. If it's warmer, significantly warmer or colder than your body, you're gonna feel radiant transfer. Also, if you have poor insulation, there's going to be big temperature swings. And when you have big temperature swings, a lot of people start to do some crazy things with HVAC equipment. It's probably not the equipment that's causing the temperature swings. Most likely hopefully you sized it right and you selected the right piece of equipment. It's probably not that. It's probably the performance of the house, and you have to fix the home, not put in bigger or better or more efficient or more zones, right? We have to fix the performance of the house first in order for that person to feel comfortable in that home. And trust me, at my house, it's an old Victorian. We've done a lot of work when it comes to air sealing and insulation just to try to feel comfortable in some of our rooms. Newer construction is probably a little less of a concern because you're at a very minimal amount of difference when it comes to, if I was to add insulation, it's not going to make a big difference because the code when that was constructed already required, let's say, R18 or R30 or R32 or whatever it is upstairs. So depending on the age of the house, this can make a bigger impact when it comes to comfort and temperature swings. All right, so when it comes to air leakage of the house, I'm willing to bet, unfortunately, most of the guys and gals that are watching this video are HVAC contractors. You probably don't own a blower door. So it's really, really hard to find drafts in a house or to measure the air changes per hour in a home if you don't have the tool to measure it, okay? So usually it's an educated guess. And of course, if you're an elite member, you probably walked through some of my guidance when it comes to infiltration in a home in previous videos under the system design videos. Obviously, if you're not, as an elite member, you get full access to the system design training. And based on construction, you can take some educated guesses on the air leakage of the home. Obviously, if it's been weatherized, it's going to be better than what the educated guess is. Ideally, you're not guessing and you're measuring. I know that's probably a stretch for most of you guys, but if you're going to measure, then you will know where the drafts are and you can address it. Most likely, if you have big temperature swings in rooms and you can see curtains move like in my living room, you have a pretty big draft you need to address. Turns out mine was the old fireplace. I had to put a pillow in there, all right? Also, when you have a lot of air leakage in the summertime, you're going to have a big humidity problem, particularly coming up from basements in the Northeast, right? There's a lot of crawl spaces and unfinished basements, and if it's not air sealed with insulation and a slab, you're going to get humidity and temperature differences across those floors, and you're going to add a lot, especially if you have a lot of duct leakage in a basement, because you're going to have negative pressure pulling in all of that moisture. Just like temperature goes from hot to cold, moisture goes from high content, high relative humidity to low relative humidity. So if you're bringing back lower relative humidity air from upstairs and you're sucking in high humidity, obviously that moisture just going right into the return duct. See that a lot with open filter slots, things like that around the furnace. You want to address any obvious stuff that you can see into the ductwork. Do that first. Large leaks first, then worry about all the boots and all those other things. Pan bays is another one. Really, really hard to seal a pan bay. Probably just want to duct it. You shouldn't be installing pan bays these days either anymore. Moisture migration. If you can't control moisture in a home, it's going to not only do physical damage, but obviously you're going to have a lot of comfort problems in the home. So first off, is there a vapor barrier? So in my crawl space, I had an old foundation, right? An old basement downstairs. We put a vapor barrier down. It was thin mill plastic, all right, and air sealed all the way around it. And now we controlled the moisture for coming in from the basement. Vapor barriers on newer construction home are going to be all the way around the house, right? Obviously, you need to know what the conditions are. And just because you have air leakage or moisture migration in one room does not mean it's the comfort issue is going to be isolated to that one room. It's probably going to affect the entire floor because the air has to go back to the unit to remove moisture. That's where the moisture comes off the coil, right? So if you have, let's say, ductless all on the first floor, it probably could be controlled in that one room because you have a ductless wall mount in that one room. If you have a ducted system on the whole first floor, the air and moisture is going to mix in the entire first floor to get back to those returns in order to come back to the coil to remove that moisture. We only change sensible temperature in each room with airflow. Right? Moisture is removed at the coil. It's going to affect the entire home if you can't control the moisture in a house. So really, really important. Check vapor barriers. I know that's part of site survey here, but you have to know what you're looking for in order to address the real problem in the home before you start offering zoning. okay? And then of course, humidity control. Humidity control is not just in the summertime. I know that's when we always worry about it because that's when it affects our comfort the most, but it does affect comfort and health in the wintertime as well. Ideal humidity sometimes is anywhere between 30 to 60%, and that's when the least amount of fungus and viruses grow. Of course, everybody's probably up on this these days under these COVID restrictions in 2021 and 2020. It's really important if you don't have a whole home humidifier in the wintertime, make sure you're addressing the local areas where you're spending the most time, like your bedroom or your living room. And if you don't, you're gonna notice as a humidity issue, it's gonna be really low when you see a lot of static electricity in the home, okay? I personally feel it every time put the light switch on. I always joke, I feel like Emperor Palpatine, right? Just shooting out electricity from my hands. I'm almost conditioned now to know it's coming. Like when I was a technician and I was very hesitant when I first started to put my meter on a contactor or something. I was very, now I'm doing that with light switches because it's so dry in my house. So we have to make sure we control that humidity. And in the summertime, it's just as important because if the temperature of a wall or window or door gets below the dew point of the air, you're going to get that moisture like you see on this window. Now, we typically see this a lot when we over humidify in the wintertime. It's really easy to do this. That's how we know we're adding too much humidity. We would turn the humidifier down, right? At this point, it's too late, obviously, because now you're seeing visible. Who knows what happens when you talk about infiltration inside a wall and all that stuff. That's worse. In the summertime, obviously you're going to have a comfort problem if you're removing moisture. You almost, especially in the Northeast, can't remove enough moisture in the summertime in order to feel comfortable. And that's why people start turning their thermostats lower and lower and lower. If you have a properly sized system that runs all the time, 75 degrees and 50% relative humidity is actually pretty cold, all right? Nobody's going to believe you when the relative humidity is 55, 60% and you feel warm. And you're gonna feel cold and clammy because they're gonna keep turning that thermostat down. You gotta control the moisture in a house. So if you can't control it with just your air conditioning system, you put in a whole house dehumidifier to supplement it, right? Obviously we can control it sometimes with ventilation air. We're gonna dilute it. That's one possibility. But if you don't have balanced ventilation, we're gonna be pulling air in if we depressurize rooms in the house. So humidity control is not just about diluting. You also have to remove it. And of course, if you're running at part load and you're not able to turn the fan speed down, you're gonna end up with excess moisture in the home. What ends up being a single stage system or a two-stage system, and you can't turn down far enough to match the load when you're not at design temperatures, it's gonna short cycle. And what's gonna end up happening here, if you zone the system out and you can't ramp down the fan airflow to just that zone, you're gonna make excess moisture in the home worse because it's gonna short cycle more and you're gonna have bypass air and you're gonna be dumping cold air into other spaces and you're gonna over cool and you're gonna raise the relative humidity, all right? So this is why we have to look at humidity control and the amount of moisture that needs to come out of that volume of air in a home and apply humidifiers or dehumidifiers, right? And not just try to zone a section of the home thinking if I can force more cold air there, it's gonna be better. Bigger's not better, all right? We gotta control the condition that we feel for comfort, all right? Humidity is a huge part of that. I know I'm harping on this. I wanna make sure you guys understand how important this is, all right? I always laugh when I hear about this, all right? Load calc errors. I know nobody watching this makes errors on their load calcs, right? So, and everybody does load calcs, but you gotta remember, when I say a load calc error, it's not an obvious error. You guys hopefully know the difference between a vinyl framed window and a wood framed window, single pane or double pane. Hopefully you guys understand the basics there, all right? What I want you guys to understand, if you make a error on the load calculation, this is the system design map. This is your map before you enter the woods, right? If you've heard some of my in-person talks. What you're gonna find is if you make an error on the first step, when you select equipment with manual S, that error gets magnified. And then when you design the ductwork, that error gets magnified. And when you make obvious errors based on design temperatures across every wall, door, window, floor, every device, that then gets magnified every step of the way. It's not just on your load calc, it's equipment selection and duct sizing. And that's why zoning a bad duct system is zoning an oversized air handler and zoning a bad load calc. Zoning is not gonna fix it. The original portion of that is probably a load calc error. So design temperature is the number one thing. Obviously table 1A, you're gonna make sure you match your outdoor design conditions based on the 99% or 1% design temperatures for your location. And then indoor, it's defined by the International Residential Code and is part of building code. Obviously, if you don't know what those are, there's many resources here. I'm just going to rattle them off for you though. In heat, it's 70 degrees plus or minus 2 is the only leeway. Low is 68, high is 72 inside. In the summertime, it's 75 degrees and 50% relative humidity. No room for going lower. All right, you can't design to 70 because the homeowner wants it or whatever other reason you guys come up with. All right, got to design based on code. That way you can control the humidity and the comfort in the space, and you don't need to address all of these problems afterwards. R value, across every wall and window and door. Obviously, if you're within a couple of numbers here, if it's really R12 and you put in R13, it's not gonna be a problem. You're gonna be close enough, same size piece of equipment. It's when you say there's R0 and there's really R19 in a wall. That's a problem, okay? So obvious load calc errors. Infiltration, if you have a leak, if you set your house for leaky and you have a brand new construction home as a passive home, obviously you're gonna oversize the system. It's gonna be drastically different in the load. If you measure, you know the air changes per hour, you can enter that number. And then of course, don't apply any safety factors. There's so much rounding already built into the software. I was fortunately trained years ago by Mr. Hank Rakowski, the PE that wrote the ACA manuals, okay? And he said, because software has to stop the rounding, you gotta stop somewhere. If you do an aggressive load calculation, you're still gonna come out with a system that's 20% larger than what the real house needs. And then you can oversize even more in Manual S, and then the ductwork needs to match that. So imagine, you could be 20% bigger with the most aggressive load calc, and then let's say another 15,000 BTUs larger with a heat pump on top of that, and you're still meeting code. So it's really important you do this work correctly to set yourself up for a house that's comfortable and you're not trying to throw equipment and stuff at it afterwards, okay? No safety factors. You're not doing anybody a solid by making it a half a ton or a ton larger, okay? Even if it's variable speed equipment. I have many times explained that in the last few years why variable speed equipment is not always the answer. You can oversize variable speed equipment too. It doesn't turn down to 1 BTU. Everybody's scared of this. Undersized equipment. Right? You do a load calc, you put it in, and now it's too small. And guess what? It's your fault. Homeowner's gonna hold you responsible for this. But even though this is possible, it's very uncommon. And if it is happening, it's because you're not doing your load calculation correctly, right? It's obvious. Because of the ability of oversizing. Think about how bad that has to be for you to be too small in that process, right? If you're doing an aggressive load calculation, and it's going to oversize already by 20% of what's built in per Hank Rakowski, right? And then you can oversize slightly larger based on what's allowed by design and code in the Manual S process. If you put in undersized equipment, that is a huge mistake on your part. You couldn't do this if you're doing the process right. It's when people guess when they put in undersized equipment. Think about what's going to happen here. If you have undersized equipment, you're not going to have comfort in any of the rooms. All of the rooms, when you're at or above design temperatures, are not going to be comfortable. It's not one room. If it's one room, then you might have a design issue when it comes to your duct size or air sealing or balancing or something along those lines, right? Or just the way the system was set up, right? The way it was commissioned. You didn't set it up for the right airflow. There's all kinds of possibilities there why you don't have comfort to one room. That doesn't mean you have undersized equipment if you have uncomfortable spaces. If you have an uncomfortable house, most likely it's undersized equipment, okay? The entire home. And you would have to do another load calculation to verify that. Obviously, I would assume it's somebody else's problem originally that you inherited if it's undersized equipment. If not, we really need to talk about how to do site survey. The opposite side of that is obviously oversized equipment, and this is way more common, okay? When you have oversized air conditioning equipment, you're gonna have real problem controlling humidity. It's gonna short cycle, right? Everybody knows this. Also, if you zone, and if you guys remember making zoning decisions last month, we talked about load patterns and matching the correct rooms, right, with the CH ratios. If you match incompatible load pattern rooms, no wonders you're going to have oversized equipment and short cycling, and you're going to have uncomfortable spaces. So just because you zoned the house doesn't mean you zoned the house correctly. And that could lead to oversizing as well. Even though this is somewhat common, it's not very common. Oversized equipment, especially with the technology these days, is less likely to happen because most likely people are zoning high efficiency equipment. If you're still zoning single stage equipment with bypass and dump zones, we need to have a different conversation than the last couple months here. Certainly, if you think there's not a better way to do it, reach out to me. Shoot me an email. I'm more than happy to talk you through. Or if you're an elite member, let's talk about it on our 30-minute monthly call, okay? I'm more than happy to address any concerns on that end. Undersized ducts. When I see duct drawings like this, now this might be just a sketch for somebody that's going out into the field, and maybe they did do the manual D worksheet, but probably not, right? I mean, look at this thing. This is probably a flex monster in the attic. So when you have the correct equipment capacity, that doesn't mean that's what's being delivered to the space, especially if it's in an attic or a basement, all right? If it's outside the conditioned space, outside the building envelope in an attic, obviously you can have duct losses and gains. So equipment capacity versus what's being delivered to the space are two different things. Now, your losses and gains should be accounted for in your load calc, and you should be sizing it correctly. It's accounted for, okay? So you don't need to make the ducts bigger in order to get more air. It's not how it works, okay? What you do need to do is make sure that you install dampers, all right, at each takeoff by the trunk, because you're doing trunk and branch systems. We're not doing flex monsters, right? What that will do is when you increase the static pressure, you'll be able to modify it. Just putting a damper in is not going to fix an airflow problem. By dampering and zoning pieces of the duct system, all right, it's not going to fix a comfort issue elsewhere. In fact, it probably could make it worse, because when you put a damper in, right, think about it, you're going to increase the static pressure, and the more static pressure you have on a system, you're either going to use more energy with an ECM motor, or you're going to decrease the airflow with a split capacitor motor. So the higher the static goes by putting these dampers in, the less volume of air you get to a space. Dampers, whether they're automated or physical hand dampers, do not fix comfort problems in a space unless you didn't balance. Okay, we'll talk about that in a second. Now, oversized ducts, believe it or not, this is a big problem in the Northeast. We have a lot of, this is a gravity type system. If you guys have ever seen one of these, oil, coal, even some gas conversion, where you'll notice there's no blower, okay? Heat goes from hot to cold, and obviously it's more buoyant, so it rises. So this creates natural convection in a house, and these systems were very leaky, all right? You can't just replace that convection furnace with a forced air furnace and expect that ductwork to work right, or think you're going to throw an A coil on top of it and think the air conditioner is going to work. You're going to have a sweating mess in the summertime down there. What ends up happening is if the ductwork's too large, you're going to have really low velocity, and the outlets for each room are going to be too big because you have ductwork that's too big. And now this feeds into the next section here. Duct leakage. If you can't get the airflow to where it needs to go, whether it's in the supply where you're leaking it out, you're going to have low velocity at that register. You're not going to be able to throw the air where it needs to go. I'll show you in a second. Or you're sucking in a lot of hot attic air or moisture in the basement like I talked about at the beginning of this presentation. Duct leakage really affects capacity, and affects comfort in the home, and it makes it almost impossible to balance a system. You need the duct leakage really low. It needs to meet code, okay? If we have poor supply air outlet performance because of duct leakage, or the register's too large, or it's not the right register for the application. And when you select registers based on manual T, remember when that air comes in, you're gonna throw the air in air conditioning as far as you can to mix the air in the room. So if you have a floor register and you have an 8-foot ceiling, you should make sure that throw is 8 feet in order to mix the air in the room. There's no dead spots in the space, right? So the location of the register is really important. The style and the size is really important. Style not meaning it looks good, but the style is the throw, the spread, and what's gonna happen with aspiration in order to mix the air in the room with stratification. And the entrance condition of the air is what is important. How fast it's moving and what the temperature is. So if you have really well-sealed ductwork, but it's not insulated well, that's another problem. And by putting variable speed systems in, when it ramps down, by the time the air reaches the end, it might be warmer than what it used to be. And if you didn't fix the ductwork, a new system or zoning a system is not going to be the answer. You got to fix the delivery of the BTUs, the ductwork, right? Just like if we didn't have enough baseboard with an oil boiler or a gas boiler, we can't put a variable speed boiler in and zone it and force the water through faster because we don't have enough convection in the space. It's not going to heat the space because there's not enough delivery. There's not enough ductwork, right? Or in that case, convection. So really, really important. Got to deliver the BTUs to the space and get the BTUs back. All right, returns as well. Speaking of returns, if you have inadequate return air, what ends up happening is you're gonna try to pull all of that volume of air from one spot in the house. I see this a lot with old duct systems and attics where you have a central return in a hallway. And if you don't have a low resistance path for those rooms to get the air back to that return, you start depressurizing the hallway, all right? Every room that you add supply air to needs either a low resistance path by adding a transfer grill or whatever, or a return in that room. You cannot isolate parts of the house and expect it to be comfortable. All right, it's really, really important. If that room can be isolated, you have one or two options: a transfer grill or its own return. Undercutting a door this much is not going to be adequate return air, and you have to depressurize the hallway significantly to pull that air back out. So really, really important. Keep those rooms balanced, all right? There is a process on measuring the pressure difference across doors into different spaces to know if I need to add or fix return air in that room. BPI does a great job walking you through that process if you go to bpi.org. One of the common methods for a service tech when they have big temperature differences across floors or rooms is to just run the fan constantly. Unfortunately, when you do this, a lot of times in air conditioning, in cooling mode, you're gonna end up not cycling the fan off and letting the moisture drain off the coil. What ends up happening is when the air conditioner shuts off and the fan continues to run, you actually redistribute that moisture back into the air and you start pushing that moisture back into the space. Obviously, when you're running the fan all the time, we're gonna increase the electrical usage as well. So this is a temporary solution to a bigger problem, and it's just gonna create other issues, right? So even though you're gonna cut down the temperature difference across the rooms, you may increase the humidity and they're not gonna feel comfortable. You're certainly gonna increase their electric bill and they're gonna call you after a couple months of this. And obviously, if you shut the fan down and you fix the fan speed on a low fan speed, you're gonna reduce the air outlet effectiveness because the velocity is gonna go down. And you're not gonna be able to mix the air in the room. And what ends up happening is if you have a lot of periods where you fix the airflow really low, you're gonna have uncomfortable rooms as you get further away from the system because the static pressure is lower, because the airflow is lower, which means the velocity is lower. And you're gonna have hot and cold spots in that space, and then that's when radiant asymmetry really it becomes obvious, especially in the summertime. Now, don't get me wrong, heat does go from hot to cold, and you might not have a big temperature difference across those rooms when you turn the fan speed way down, but you're certainly not gonna be mixing the air in that space. And if you're not gonna be pulling air back from that space, that's when you start feeling that radiant heat loss and heat gain. And then of course, air balancing. If you don't balance a system, all right, air balancing is not reserved just for commercial spaces, even though that's when it's probably enforced. Manual B walks you through air and hydronic systems in a home, residentially and commercially. What you need to air balance, obviously, is a hand damper at the takeoffs at the trunk. You don't balance at the register. That's gonna create velocity noise and most likely aspiration issues with condensation issues in the summertime because the air is gonna start recirculating. It's actually going to make that temperature of that device colder. And if it's metal, it's going to get below the dew point of the air. Testing and balancing is part of the commissioning process. Make sure you're finding a way to measure the volume of air delivered to the space, and you're within, let's say, 10% of what the design is for that space. That's really, really important to follow up and make sure you commission the entire system, not just getting the airflow and refrigerant charge right on an air conditioner or heat pump, right? You also have to deliver it to the space, and this completes that commissioning process. To answer the question, will zoning fix it? Well, I think you're gonna find it's not always the answer, all right? Now, if it's a single zone system, I gotta tell you, there's many better ways to fix issues in a house than to zone out a single zone system. Single zone systems, I'm gonna be honest, it's just old technology and an old way to heat and cool a home. Everybody that buys a house, that lives in a home, finds comfort issues, whether they're there for one day or 10 years. So if you ask in the process, do you have any rooms that are uncomfortable? And you start to figure out that these are the ones furthest away from the space. You have a single zone system with one thermostat on the first floor, big temperature differences across floors. You're much better off zoning with equipment and then possibly zoning the ductwork off of that equipment if you need to. Obviously, zoning does not fix design errors. You have to walk through the design process correctly. And if you didn't design the system, you probably want to go back if they have comfort problems and make sure it's designed correctly. I'm willing to bet probably wasn't if it wasn't you guys. Obviously, you got to know the right methods and materials in order to really zone the system right. There are many different ways of zoning a system. There's the basic bypass and dump zones. There's a lot of variable position dampers that don't require bypass systems. And in fact, there's some ductless manufacturers that make ducted systems that will not let you use a bypass duct. You have to use their zoning system for the system to operate correctly and efficiently. So before you go through all of this quoting and all of this process, verify that the zoning is appropriate. Make sure that the comfort issues can't be fixed easily first, because the easy answer is probably the right answer. And you don't want to sell somebody a zoning system and do all of that work and then find out we didn't address the comfort problem in the space. That's what the people want. Homeowners want the comfort. Zoning may be the answer after you verify all of these things. So what did you think? Did you like the training on comfort problems and causes of temperature issues in the house? If you did, you can get videos like this 1 year early by subscribing to my Patreon page for as little as $8 a month. If you like system design training or you're looking for details when it comes to site survey, equipment selection, and how to size ductwork, we have options for recorded trainings and immediate access as little as $75 a month. And that includes Zoom meetings one-on-one with me monthly. Looking forward to seeing you over on Patreon. I'm Chris with HVAC Pro Blog, where we provide advice for residential system design, quality installation, and system diagnosis. I'll see you next week.